Another class. I'm Dr. B, your science teacher online. Today, we are going to be discussing alkynes. Alkynes. Now, do not forget that alkynes belongs to that large topic called hydrocarbons. You and I have done something concerning hydrocarbons. We have discussed alkanes. We have also discussed alkenes. Now, if you scroll through my videos, you will see that these topics have been treated. Alkanes and alkenes. Now, I promised us that we're going to conclude on the topic hydrocarbons, especially on the aspects of the three major groups of hydrocarbons by treating the alkynes. Do not forget that you are supposed to share this class. That is what you owe me. You are supposed to also like and leave comments, even if there are questions. I will attend to them. You're also expected to go to the subscription button and click on the subscription. And subscription to this particular channel is free. You don't need to pay anything. Now we also have the Facebook page. All you need to do there is to share as well, and then while you share, tell your groups of friends to like, to also comment, but most importantly, tell them to follow. All right, now it's Dr. B Science Classes. That is the name. Okay, so now we are going to be looking at alkynes as a branch of hydrocarbon. I want us to know that the alkynes are very different from the alkanes. Now, alkanes, like we have said before, are completely saturated hydrocarbons. We have discussed exhaustively on this already. Just go back to my videos down there and you're going to see the discussion on alkanes. Okay, so alkynes are also different from alkenes. Okay, remember that we have, like we said, we have the alkanes. We also have the alkenes. And we have the alkynes. Okay, so you can see that the alkanes end with the ANE, and the alkenes ENE, and the alkynes YNE. Now, talking about the alkynes, I want you to know that alkynes are classified as unsaturated hydrocarbon. So the alkenes and alkynes are unsaturated hydrocarbons, unlike the alkanes, which are saturated hydrocarbons. As a matter of fact, why do we classify them in that way? Of course, the alkanes are classified as saturated hydrocarbons because they have just single carbon-to-carbon bond. They have just one bond that connects their carbon atom. Now, but alkenes and alkynes possesses two bonds and also three bonds that bond their carbon atom. Now, that makes them also what unsaturated hydrocarbons. But there, away from there, you can also classify, you can also define why they are being classified as saturated and unsaturated based on their hybridization. We have already discussed all this in our previous classes. Now today, I want us to know that alkynes are simply unsaturated hydrocarbons. So you can see them existing with triple bonds. Okay, so alkynes are known to have triple bonds. Okay, so you look at an alkyne to have 1, 2, 3 bonds. Alright, so alkynes have triple bonds, but something very important you need to know is that alkynes with their triple bonds have a functional group that is very unique. Now, this is more like a functional group for the alkynes. Okay, the C, triple bond C, is a functional group for the alkynes. And of course, the alkenes functional group is just the C double bond. Now, these alkynes are very, very reactive, unlike their corresponding what? Alkane and alkenes. Alkanes are not even that reactive compared to alkenes, but alkynes are more reactive than the two of them. And this is because their functional group has sp hybridized carbon atoms. Okay, so this carbon atom is sp, this one is also sp. So the alkynes possesses sp carbon hybridized carbon atoms. that are being bonded together by a single sigma bond. The bond that is inside here is a sigma bond. Sorry, it's a sigma bond. And these two bonds here are the pi bonds. So you see that alkynes possess a middle sigma bond and outer pi bonds. That makes alkyne to be highly reactive. That is why we say alkynes are more reactive than their corresponding alkenes and alkanes, because they possess sp hybridized carbon atoms that are bonded together by two pi bonds and a central what? A central sigma bond. Now the presence of these two pi bonds releases what we would claim to be pi electrons. So with two pi bonds, there is an electron-rich center for an alkyne. Because of the electron-rich center, it gives the alkyne an opportunity to be highly reactive. And that is why alkynes are used vigorously, are used more frequently in most production. It might interest you to know that most of the synthetic materials like ethanol, like detergents, okay, like antifreeze agents are produced from alkynes, either ethyne, okay, or even butane. So you can see that, like I said, more productions are being made out of alkynes because of their electron-rich center due to the presence of two pi bonds that are there. So you can also see that away from even the production of synthetic materials like alcohols, like antifreeze, like even antifreeze agents, okay, that we are talking about, detergents, we can also use them in production of some plastics, okay, some plastic material. For example, polyethylene. Okay, polyethylene is made from a type of what? An alkyne. Okay, things like vinyl plastics, like the polyvinyl plastics, they are all from alkynes. Things like acrylics, okay, things like acrylics, they are all from alkynes. So alkynes are highly reactive, and because of their high reactivity, due to their electron-rich center, because they possess two pi bonds and a sigma bond with carbons that are sp hybridized, you can use them to produce so many things. Now let us bring ourselves a little bit again further about alkynes. Now, do you know that alkynes have odor? Just like we discussed alkanes, we said alkanes do not really have odor, but the alkynes have odor, and that makes alkynes quite different from other hydrocarbons. They have odor. Now, you can take, for example, something like ethyne. Okay, let's look at ethyne. Ethyne is quite simple. Let's look at ethyne. Okay, ethyne is a type of what? A type of alkyne. Ethyne, if you prepare ethyne from calcium carbide, okay, calcium carbide is this. If you prepare ethyne from calcium carbide, you will notice that the ethyne you're going to have will have an odor, more like a garlic smell. More like a garlic smell. So depending on what you use to produce an alkyne, you will have a particular odor that comes with it. Okay, so ethyne as an alkyne has an odor like garlic, especially if it is produced from calcium carbide. And usually it is because of the impurities that are present in that ethyne. Impurities of hydrogen sulfide, impurities of phosphine. Okay, right. Impurities of phosphine, impurities of hydrogen sulfide comes with the production of ethyne using calcium carbide, and that gives ethyne that odor, that garlic odor that you find. Ethyne is highly explosive, okay, and a very poisonous gas. So you don't joke with ethyne when you are working with it. It is highly poisonous and has explosive nature as well. Now let us come down a little bit to some properties of them. Now, understanding the fact that ethane itself has odor, also we must know that ethane has a melting point that is around 8.3. Okay, but far away from the melting point. Okay, ethane is lighter than air. Okay, so you can imagine that. So ethane is quite lighter, very light. Okay, so you can possibly collect ethane even if it's not over water. So ethane is lighter, but the chemical properties that explain ethane are very unique. One of the most important property you must not forget while talking about ethane is combustion. Ethane is highly flammable. I've told you here that ethane, through its functional group, ethane shows that it is highly reactive. So ethane is what? Highly combustible, highly inflammable. So for example, if you react ethane, ethane, okay, as an alkyne. If you react ethane, let's say 2C2H2, okay, as an ethane, react it with water, with oxygen rather, you will get carbon dioxide, you will have water, and you will have heat giving up. Now you can see that the combustion of an alkyne will always give rise to carbon dioxide gas, water, and energy. Now the presence of this energy is quite very high in an alkyne chemical reaction, and the reason why we say it is explosive in nature. Now once you react 2 molecules of ethane, which is an alkyne, with 5 molecules of oxygen, you will have 4 molecules of carbon dioxide gas, 2 molecules of water, and heat. Where the problem lies is the presence of heat. So one of the basic chemical reaction of ethane that is unique is its combustional reaction. So it reacts combustively to give you carbon dioxide gas, water, and so much of heat or energy at the end of the day. Now another very important and unique chemical property of ethane is addition reaction. I have mentioned here that this, of course, is combustion reaction. Okay, so addition reaction is another unique reaction of an alkyne. So if you react an alkyne use additional reaction with alkyne, you will definitely be having the other lower hydrocarbons. That is to say, if you react additionally with alkyne, for example, catalytic hydrogenation of alkyne is an example of an addition reaction. So if you use a catalytic hydrogenation of alkyne, at the end of the day you have either an ethene, that is an alkene, or an alkane. Okay, and in some cases you can have both an alkene and then an alkane, depending on the catalyst that you use. Usually catalysts that are frequently used in catalytic hydrogenation, that is addition reaction of alkynes, are either nickel catalyst, palladium catalyst, or platinum catalyst. Those 3 catalysts are the most frequently used catalysts in the hydrogenation or in the addition reaction of alkynes. For example, if you have an alkyne, say butene, and you choose to react it with any of these catalysts, you have an alkane like butane. Now this is what we mean. So if you have butene, for example, okay, so this is butene. Okay, this is butene. So if you react butene with hydrogen, okay, it's expected that this hydrogen will break these bonds that we have here. And when it breaks this bond, you have an intermediate alkene before an alkane as a final product. So if you react this with this through the presence of either a nickel catalyst or platinum catalyst or even palladium catalyst, any of these catalysts, if you react them with this, you will have, depending on whether you use a nickel catalyst, platinum or palladium, you will have either direct alkane as a product, which is butane, or you are going to have an intermediate alkene, which is butene, before alkane, which is butane. Okay, I don't know if I'm making sense here, but let me quickly explain this again. Okay, let me write it where it will be clearer. Okay, let me use where it will be clearer. Okay, so what I'm saying is this, that addition reaction is one very important reaction that has to do with alkynes. And the addition reaction in alkynes as a chemical reaction of alkyne is also called catalytic hydrogenation. And once this hydrogenation in the presence of catalyst comes in the way of an alkyne, it is going to remove the triple bonds and substitute them to either give you an alkene, which is a double bond, or give you an alkane, which is what? A saturated hydrocarbon. And we took an example here. We said if we have this CH3, CH3, and we said this is butene, this is an alkane, this is an alkyne, okay. And if we react this with hydrogen, we will either use nickel catalyst, platinum catalyst, or palladium catalyst. Now, if you use a nickel catalyst, for example, this hydrogen will substitute these particular triple bonds and give you an alkane, which is a saturated hydrocarbon. But in some cases, you may use platinum or palladium catalyst, and it will first give you an intermediate. So you will have this result as CH3 to CH2 to CH2 to CH3, and this is butane, which is an alkane. This is butane, which is an alkane. This is a direct hydrogenation of butene, which is an alkyne, to give you butane direct. But in some cases, you might use platinum catalyst, and it will give you an intermediate which will have a double bond here. That is to say, you might be having CH3 to C to double bond to C to CH3. And this will give you here an alkane, or probably CH, alright? CH as the case may be, because this is double bond, so you may have CH here. So this will give you an alkane, as the case may be. An alkene rather. An alkene, A-L-K-E-N-E, because of the presence of the double bond. So sometimes, depending on this particular catalyst, you will have an intermediate alkene before you now have the product, which is an alkane. But you might use another type of catalyst in here, and you will arrive directly at an alkane. But what you have to know is this, is that in any chemical, in any catalytic hydrogenation, nickel catalyst, platinum and palladium catalysts are used, and the products will be the lower hydrocarbons, either alkene or alkane, or both alkene and alkane. We have spoken much already concerning these alkynes. We can go on and keep talking about alkynes, but for the purpose of time, we are going to stop here today. And this has been a very interesting class so far. So with these alkynes, we have brought ourselves to the conclusion of the three categories of hydrocarbons: alkanes, alkenes, and alkynes. I'm sure you are going to do much better for yourself if you try to go through all these three classes at once, to be able to follow them one after the other and be able to connect them as they go. It's been nice having this class with you. I'm Dr. B, and this is Dr. B Science Classes. Please, I expect that you share these classes with your mates, share it with other groups,